Hey there, hi there, ho there! Welcome to Unit 8 on Metamorphism and Metamorphic Rocks. We're going to finish up the rock cycle. So, what is metamorphism? How does it have a role in the rock cycle? That's what we'll get into. So, we've talked about igneous rocks in Unit 6. We talked about sediments and sedimentary rocks in Unit 7. Now in Unit 8 we're going to be over here in this realm with metamorphism and metamorphic rocks. Influenced by Earth's internal energy, kind of coming full circle back into the plate tectonic cycle. Next unit we'll kind of talk about some additional information as it relates to plate tectonics and metamorphic rocks before we transition over to the hydrologic cycle. So, what is metamorphism? Sometimes I like to break down the words to help me understand what this stuff is all about. So, meta is a prefix that just means it denotes a change in condition. Morph means form. Therefore, metamorphism is a change in form from one rock to another. So, like the mighty morphing Power Rangers, they're changing their form. So, metamorphism. We're going from one rock to another one. Now, a change from one rock to a new rock can be mineralogical, so the minerals can change. Textural, the look of it. Chemical makeup, rearranging the internal chemical structure. Structural change, changing the way things are layered or in the rock itself. And all of this occurs below the area of diagenesis. Diagenesis is the area where sedimentary rocks are formed. Remember back to last unit we talked about compaction and cementation. You need a little bit of heat and a little bit of pressure for that to occur. Well, below that, where there's more pressure and more heat, that's where metamorphism occurs. So, metamorphic rocks are created as a result of exposure to high temperatures and or high pressure. So when we're making metamorphic rocks, they start off as some other rocks. We apply heat and pressure to get a new rock. Well, the original rock is called a protolith. Protolith. Again, breaking down words helps me understand things sometimes. Proto is a prefix that means first. Prototype, it's the first type. So proto means first. Lith comes from the Greek word lithos, meaning rock. So protolith is the first rock, the original unmetamorphosed rock from which a given metamorphic rock is formed. So the original, what's known as the parent rock. So you take some original parent rock, you apply heat and pressure, and you get a new metamorphic rock. Different metamorphic rocks are created due to differences in heat and pressure. And we call this, the amount of heat and pressure, the grades of metamorphism. So for instance, a low-grade metamorphic rock is formed under temperatures and pressures or conditions up to 400 degrees Celsius and 400 megapascals of pressure. Megapascal is just a unit of pressure. I'll give you some meaning to what that number is. This kind of conditions can be found about 5 to 15 kilometers below the Earth's surface. So from 0 to 5 kilometers below the Earth's surface, that's where diagenesis can occur, sedimentary rocks. Below that, from 5 to 15 kilometers below Earth's surface, the temperature increases, the pressure increases. You can create low-grade metamorphic rocks. From 15 kilometers down to 35 kilometers below the Earth's surface, that's where high-grade metamorphic rocks are created. These are conditions higher than about 400 degrees Celsius and greater than 400 megapascals of pressure. Below that, 35 kilometers or below, in general, there's too much heat, too much pressure, things will melt. Now we're back into magma, now we're back into the igneous realm. So, metamorphic rocks, just enough heat, just enough pressure to change them somehow, but without melting them. Because if they melted, now we're back over into the igneous side of the rock cycle. So 400 degrees Celsius is hot, but what about that number, 400 megapascals of pressure? Well, let me give you some reference. 400 degrees Celsius is 750 degrees Fahrenheit. So just take the, a summertime temperature in Phoenix and multiply it by 7. That's hot. But what about this pressure? So just to give you some reference, in the United States, if you go to put air in your tire, it's measured in psi, pounds per square inch. Megapascals is just the metric unit of measuring pressure. So a typical tire, the air in your tire in this scale would have about 0.2 megapascals of pressure. A human bike can apply 1.1 megapascals of pressure. So to create metamorphic rocks, you need 400 times that, essentially. Car wash spray. Have you ever been to those car washes you drive into and you get the hose from the side and you spray off your car? There's a lot of pressure there. If you've ever hit someone with it, it stings a bit. You can get up to about 5 megapascals of pressure. Hell, even a bullet is 21 megapascals of pressure. So 21 megapascals of pressure is enough to, obviously kill you. So again, 400 megapascals of pressure. That's a lot. Mariana Trench. So this is the lowest point in the ocean. It's over near Japan and the Philippines, over in that area. It's the bottom of the Pacific Ocean at a convergent boundary where there's a subduction zone, and there's enough subduction to create a little trench at that subduction zone, creating the lowest elevation on Earth, the Mariana Trench. The deeper you go down in the ocean, the more pressure because there's more water above you. So at that very deepest part of the ocean, you can see it's 110 megapascals of pressure. So obviously, if a bullet kills you with 21 megapascals of pressure, that's enough to obviously kill you. But still, not the pressure we would feel as we get further in Earth. The reason you feel more pressure the further down you go in Earth, because there's more material on top of you, essentially squishing you. So just a little reference. So just to give you a cross-section of Earth visual with the conditions that we might find there. So again, from about, you can see from about 0 to 5 kilometers depth, the region of diagenesis exists. So somewhere in here. So these conditions, temperature on this scale, pressure on this scale. So, 100 degrees Celsius, 100 megapascals of pressure. That's the conditions we would find about 2.5 kilometers below Earth. And that is the region of diagenesis where sedimentary rocks are created. Metamorphic rocks are created in this low grade or high grade. So make sure you understand how this table works. I'll explain it because just in case you have questions on it. So if for some reason there's a question, if I said, okay, at 300 degrees Celsius temperature, which is up here, and 300 megapascals of pressure, what kind of rock would be created under these conditions? Well, the answer is a low-grade metamorphic rock. Okay, what about 800 megapascals of pressure and 600 degrees Celsius? Well, that would be a high-grade metamorphic rock. This band down the middle indicates kind of the typical area in which you would find rocks are usually under here. Under these conditions of temperature, pressure associated with depth. You can get, temperature. So let's say only 100 megapascals of pressure, but 700 degrees Celsius. Can that metamorphose rock? Yes, it can. And that can even occur only about 2 kilometers below ground. So you just got to understand how to read this chart. But again, the most typical scenario would be in this kind of cross-hatched area. And then you get this red region. This is where melting would occur, where there's too much pressure, too much temperature, where igneous rocks are created. So if it's 1,000 megapascals of pressure at 800 degrees Celsius, that's 30 kilometers below ground. In that case, you're going to get igneous rocks created here. Okay. Well, with that being said, we'll take a pause here. So that's just kind of what metamorphism is, the grades of metamorphism, the conditions under which metamorphic rocks are created, low grade versus high grade. Diagenesis are sedimentary rocks. When things melt, that's igneous rocks. We're in that in between. We're looking at metamorphic rocks. So when we come back, we'll talk about the textures of metamorphic rocks that we see due to certain conditions of temperature and pressure. I'll see you back here in just a minute.